Mike, do you love radicals yet? Or do you love radicals? You love radicals, don't you? I think you all do by this point. We having a good time with radicals yet? What do you think? Are they awesome? Are they cool? Are they wonderful? Are they amazing? Handling? Are they fun? Yes, they are. They are all of those things, guys. So far, we have simplified radicals. We have multiplied radicals. We've done some adding and subtracting of radicals. Now we are ready to divide radicals, and it will be a blast. A couple of heads up. Number one, I forgot last time to visually and audibly speak it to you, so I literally communicated it to you. I wrote on our Facebook post that our quiz was assigned 2 class periods ago, so I don't want to make that mistake twice and not audibly and visually give you your quiz assignment, and that is quiz number 2. So as of today, quiz number 2, guys, will officially be signed. So, having gotten that out of the way, I do want to mention to you an important rule as we get going. And you'll notice that this is the inverse or the opposite, but it's the same concept of the rule that we had yesterday and really even the day before that. It's just involving the division of terms that are under a square root symbol. And if you have x over y as a fraction, which another way, of course, of saying that is x divided by y, and it's all under the same root symbol to the nth power, which could be squared, could be cubed, could be whatever, right? You can break those up into a single to that nth power, the square root of x over y, square root of y, to that same nth power. Or if you have it split up, you can put them under one happy marital / kind of divorce too, because they're being divided, square root symbol. And so if you have it this way, but it helps you to do it that way, do it. If you have it this way, but it helps you to do it that way, do it. Actually, a few of these, I'm going to show you, we need to do it both ways at least once within the same problem. So those are the ones that get kind of complicated. But right now it's not overly complicated. Let's start with a simple one. The square root of 40 divided by the square roots of 5. Square root of 40 divided by the square root of 5. I don't like those being apart. I want to join them in holy divisive matrimony. And so what I'm going to do is I'm going to do one square root symbol, okay? And I'm going to put that 40 as my numerator. And since it's divided by, that's what a denominator does, it causes division, divided by 5, I'm going to put that 5 as such. Because my rule of dividing radicals tells me that I may do so, and I will. And guys, here's why I've done that one. When they're separated, they don't have a common base, at least not in the outset, but they easily can be combined by simple division. What's 40 divided by 5? 40 divided by 5 is 8. And look, I already have it down just to one term, square root of 8. See how fast and how easy that is to take 2 that are apart and to bring them together in division under the same square root symbol. Now, what I have to ask myself is, can I break this down any further? And what I mean by that, is there a number that's a perfect square as a factor of 8 that I can bring from under the square root symbol to the outside? I can, and here's why. I'm just going to break down. Well, first of all, what's a factor that's a perfect square? That's 4. Keep it all underneath the square root symbol right now. What times 4, though, gets me back to where I was at 8? 2. So 4 times 2. But here's the relevance in doing that. What is, guys, the square root of 4? The square root of 4, what number times itself gets you to 4? Is the number 2. So I can move the square root of 4, which is 2, to the the outside, and I've gotten rid of that 4 that's underneath. And so what I have simplified is, I'll write it down here, I have plenty of space, 2 square root of what's left? 2. And that is written in simplified form. That's not too hard, is it? Let's do number 2. In this case, I have these separated. The square root of 15 divided by the square root of 12. I don't like that. And here's why. If I were to combine in wholly divisive divorced matrimony, if that makes any sense, if I were to combine these under one square root symbol, which the rules of dividing radicals tell me that I may, so I will. I'm going to have the square root of 15 over 12. I like doing it that way, and here's why. Whatever's found together, I can just simplify of themselves, or of itself. What is 15 over 12 reduced, that fraction reduced? What will go into each of these evenly? What number? That is the number trace. So 15, and don't forget your square root symbol though, okay? So, square root symbol, right? 15 divided by 3 is what? 5 over, or divided by, what's 12 divided by 3? 4. So 5/4. Now, here's where things get a little bit interesting. We started as separates. We moved to unity. Now, guess what we're going to do? We got to go back to separates. And here's why. Rewrite it, square root of 5 over square root of 4. Okay? Look at this. Can I break down square root of 4? Now, obviously, square root of 5, that's prime. It's just going to remain forever. But square root of 4, I just did that right up here. I know what the square root of 4 is. That's 2. Remember, square root of 5 stays. I can do nothing with that. But the square root of 4 is what number? 2. Because 2 times 2 gets me to 4 with no square root symbol at all. And so, in absolute, utter simplification, the square root of 15 over the square root of 12 is the square root of 5 over the see, I about made a mistake just in saying it, didn't I? Over 2, no square root with that. Now, this is going to be an important concept, making sure that I have no square root or no cubed root or no nth root in the denominator. Here's why. If I'm dealing with rational numbers, okay? If I'm dealing with rational numbers and it's fully in simplified form, I cannot have any root symbol with a term in the denominator. Period. Can't have it. Or it's wrong. It's not in standard form the way that it's been written. Now here it worked out well because it just naturally shrunk down into a whole number, no root symbol. Guys, it's not always going to work that way. Let me show you. Number 3, what I have is the square root of 5 over the square root of 7. Those are both prime numbers. And even if I move them into one happy marital divisive family, I still can't reduce 5/7 any more than what it is, right? And so watch this very closely. This is a brand new concept. Here is how I rationalize the denominator, meaning I get to a point where I have no square root or no root symbol of any kind, squared, cubed, or any other root in the denominator. Okay, how in the world am I going to do this? It's actually really simple because all that I do to get rid of, and we've done this 1,000 times with a million different types of problems, what I do, guys, to get rid of a denominator, all that I do is multiply the denominator by itself, okay? But if I do that, what do I also have to do to the top? The same thing I did on the bottom. I know that one looks a little funky. That's a funky chicken on top, okay? I'm just going to tell you that right now. But it's the same thing that you see on the bottom. It's just my sloppy writing, which you're familiar with that by this point. So, but look, when I multiply the square root of 7, okay, by the square root of 7, what does that give me? The square root of 7 times the square root of 7 is square root 49. What's the square root of 49? Just the number 7. I showed you that math once. I'm not going to redo that every time because we can now see the principle that's involved. When I multiply a number of a square root times that same term with the square root, all it does is give me one of those two but without the square root. Okay? In other words, that's going to simplify on the bottom just and only to the number what? Square root of 49 is 7. But does it make sense why? When I multiply the square root of a term times the square root of a term, then that's going to give me just the term itself with no square root, because those multiplied together, the square root taken of, is going to be that number multiplied by itself to get you there. Okay? So all I'm doing is just dropping the square root, but then I have to multiply out on top the square root of 5 times the square root of 7. I'm still going to have a square root, correct, on top. But what's 7 times 5? 7 5s gives me the number 35. And guys, that's my final answer right there. Square root of 35 over, not square root, but just the number 7. And now I have a correct answer because I have rationalized a prime square root denominator. And that's the way I got rid of that square root on the bottom. I just made the top number larger. Okay. How about number 4? Let's try this one. The square root of 3 divided by the square root of 6. I don't like those being separate, do you? I don't like mathematical divorce. I like to bring two parties that are at odds in math under the beautiful umbrella of holy mathematical matrimony. And so let's do that. Let's make the square root of 3 divided by the square root of 6 one big happy square root family. Okay? But we're still going to have 3 divided by 6. Now, why is it that I did that? I probably wasted some space there. But why is it that I did that? Well, because I can easily reduce 3 6. I have to keep my square root symbol, but I can easily reduce 3 6 to what fraction? That is 1/2, because 3 goes into 6 2 times. So now I have the square root of 1/2. Am I done? No, because my top number is square rooted, and my bottom number, or my denominator, is also square rooted, and I cannot have a standard form simplified answer if I have a square root that has anything to do with the denominator. And it does, even in that form. And so here's what I'm going to do. I started separate, I put them together. I'm going to break them back up again. Instead of square root of 1 over 2, I'm going to have the square root of 1 over the square root of 2. Because re-examine our dividing radicals rule, that is mathematically sound 100% to do so. But here's why. I have to get rid of that square root symbol on the bottom, the square root of 2. How do I do that? Guys, I just multiply the denominator by itself. Okay? But whatever I do to the top, or the bottom, I have to do the same to the top. And so when I multiply the bottom together, what's that going to give me? The square root of 2 times the square root of 2 is the square root of 4. What's the square root of 4? That's just a number on the bottom, and that just a number is 2. The square root of 4 is 2. But remember, the shortcut to it is when you multiply it times itself, you can just drop the square root and just take one of those two numbers without a square root, and that's the shortcut to it. But again, that's the mathematical explanation as to why. Now on top, if I have the square root of 1 times the square root of 2, I obviously still have a square root, but of what number? What's 1 times 2? 2. And so my answer is square root of 2, because I can't break down that numerator any further, but the square root of 2 divided by or over 2. And now I'm mathematically sound because I have no root symbol of any kind in my denominator. So that's numbers 1, 2, 3, 4. We will do 5 through 8 in just a moment. Picking up where we so capably left off, we are at number 5. And so write down, if you haven't already, the square root of 2 divided by the square root of 75. Now, this is one of the rare instances in this lesson in which we're just going to keep things the way they are. Split up actually helps us here, because if we put them together, we couldn't reduce 2 over 75. One's even and one's odd, and for that matter, one's an even prime number. And so we can't reduce that fraction any, so we're going to leave them the way they are. But what we are going to do is just rewrite 2, and we're going to break down 75 so that we can begin to simplify it. Do you see a perfect square number that is a factor of 75? Do you see a perfect square number that is a factor of 75? I hope so. It's a pretty easy one. It's outside the multiplication table, but it's a pretty easy one. That number is 25. We know that the square root of 25 is 5. In other words, that's a perfect square. So we really want to use 25 on the bottom. But what times 25 gets me to 75? Or if you prefer, 75 divided by 25 is what? 3 times to make that happen. Okay? So I have the square root of 2 over the square root of 25 times 3. And I've written it that way because as we keep square root of 2, we're going to be able to pull the square root of 25 out here. And what is the square root of 25? The number 5. So we can cross it out from underneath the square root symbol and move it to the outside, still being multiplied by everything on the inside. That's an important understanding. But what I have now simplified is 5 on the bottom, square root of 3. 5 square root of 3. Now, remember, I'm not done even though these are all prime numbers. I'm not done because I have to rationalize the denominator, which means I can have no root symbol in the denominator. So how do I get rid of the root symbol in the denominator? I just multiply it, not by the entire denominator, because now I have a number on the outside, but just by the root term itself. So I'm going to multiply, if you don't care, I'm going to get over here just a little bit. I'm going to multiply the whole bottom by the square root of 3, because that's the base that's messing me up on the bottom. I don't have to do anything with the 5 yet, okay? Just the square root. And whatever I do to the bottom, however, I must do to the top. And so I'm going to have to multiply the top by the square root of 3, just like I did the bottom. Now, in so doing, what is the square root of 2 times the square root of 3? On top, I'm going to have the square root of 6, because 3 times 2 is 6. I can combine those, per my rule yesterday and the day before, into 1. Now, on the bottom, I'm going to have 5 times what number? Look, square root of 3 times the square root of 3 is the square root of 9. What's the square root of 9? 3. Or, if you can remember the shortcut, whenever you multiply 2 square root terms that are the same together, you can just take or pull out one of those terms from under a square root, and there is no more square root. So I have 3 left, so 5 times 3. Okay, well, let's simplify from that point. Square root of 6 cannot break down any further because there are no perfect squares as factors of 6. That remains the same, just 3 and 2, so you see you can't do anything with those. Over, what's 5 times 3? 5 times 3 is 15. And voila, that's my answer. Square root of 6 over 15. Okay, let's give a shot to number 6. Okay, let's try number 6. 25. Square root of 3 over 9 times the square root of 15. What I'm going to do here, if you'll see, I'm going to keep everything the way it is, 25 square root 3. But if you'll notice down here, over 9, I can break down that square root of 15 more. What are 2 two common factors, and actually the only ones other than 1 and 15. What are two common and the only factors of 15? 5 and 3. And so I can write this as square root 3 times square root 5, which is the same thing as square root 15. And remember, as we're doing here, as we did the last two lessons, I can put those under the same umbrella multiplied to each other. I can separate them. It doesn't matter. Either one is correct, and all of these are saying the same thing. But watch this. This is going to help us out. Do you notice a similarity here? It helped to break down those square roots under separate symbols, and here's why. In a fraction, when I have one thing on top and I have the same thing on bottom, what can I do? Guys, I can cross that out. And I got rid of a whole square root term on top and a whole square root term on bottom just by breaking down further into factors one of the square rooted items. And so all that I have left now is, I'll write down here, all that I have left is 25, nothing square root on top left. And I have on bottom 9 square root of 5. But I'm not done, and why is that? I haven't rationalized, top right, I haven't rationalized the denominator, which is equivalent to saying I can have no root term in the denominator, period, or it's not in standard form. And so since I have a square root of 5 in the denominator, I have to get rid of that square root of 5. How do I do that? I multiply it by the same thing, square root of 5, and whatever I do on bottom, I have to do on the top. Okay? And so here's what I'm going to have. On top, 25 times the square root of 5, correct? And on bottom, what I'm going to have is 9, okay, times, what's the square root of 5 times the square root of 5? Square root of 25, or in other words, is a number, just the number 5. Okay? So I have 25 square root of 5 over 9 times 5, and remember, if I have the square root term multiplied by the same square root term, I can just take one of those two terms and drop the square root, okay? And that's, or I can do it the mathematical way if that helps me, if I need to do that. Now before I go any further than this, look, can I do something with that 5 and that 25? They have something in common, don't they? 5 will go evenly into 25 how many times? 5 times. Okay? And so now what I have, guys, is my final answer is 5 square root 5 over the number 9, and that cannot be reduced anymore. 5 square root of 5 over 9. And so I got rid of my rooted term in the denominator, so now I have a correct answer. Now number 7 is a little bit different. We haven't done one of these in this lesson before, not in dividing radicals, and that is the cubed root. Notice the 3 in there. We've done square roots all over. We're going to end with a square root, but we're going to divide cubed roots now. And those, of course, we understand by this point are different than squares. Okay, these are separated, and if I don't like that, I can bring those divided parties into holy radical mathematical matrimony under one big happy family of cubes. And so let's do that. And the reason is I notice a commonality. Do you? Between 8 and 16. I can put 8 over 16 under the same cubed root. And here's why I like to do that. How can I reduce that fraction 8 over 16? Obviously, 8 over 16, keep your cubed root sign, is nothing more than 1 over 2. But watch this. I want to break those back apart because what's the cubed root of 1? I can already simplify that without any cubed root sign. The cubed root of 1, okay, I'll write it out for you here, over the cubed root of 2. Well, the cubed root of 1 is 1, because 1 times 1 times 1 is 1. That's always an easy one. And so I'm going to rewrite that just as 1 now over the cubed roots of 2. I'm making progress, aren't I? But you see how and why I can simplify that from the cubed root of 1? Because what number times itself gets you to 1? 1. And you don't even have to have the cubed root anymore on the top. Am I done, however? No, I am not. And here is why. I have a root on the bottom. And to have a rational answer, I cannot have any kind of root, whether it's square, whether it's cube, whether it's a Spanish cuatro or cinco root. I can't have those in the denominator. And so how do I get rid of a cubed root denominator? Now, pay close attention to this. This is a little bit different than a square root. A square root, you only have to multiply it by itself once because it's what number times itself. A cubed root is what number times itself, or a total of 3 appearances instead of only 2 as with a square root. And so what I have to do, guys, is multiply the cubed root of 2 by the cubed root of 2, not once, but 2 times. Okay, and I have 3 total appearances of the cubed root of 2. And in so doing, right up here, I have to do the same thing on the top as I have done on the bottom. Okay, I had that, but then I multiplied it by itself 2 times instead of 1 because it's a cubed root, 3 appearances. And since I introduced 2 new cube roots of 2 on the bottom, I have to introduce 2 new cube roots of 2 on the top. Okay, now my purpose of doing that, what is 2 times 2 times 2? 8. What is the cubed root of 8? The cubed root of 8 is 2. And so I can just drop all cube roots on the bottom and I just have the number 2. Because I have the cube root of 2 appearing 3 times. And what you can do is just remove the cube root symbol and just leave one of the numbers. Okay, and the reason for the 3 as opposed to the 2, remember this is a cube and that's a square. In a square you need 2 to remove the symbol and just keep the number once. Well, in this case you need 3 if it's a cubed root just to remove the symbol and to keep the number once. And if you really need to do the math out, that's okay. 2 times 2 is 4. 4 times 2 is 8. What's the cube root of 8? 2. So you see that's why the shortcut works. Now on top we have 1, which is, I mean it's real, but it's insignificant. So we're just going to look at these 2 numbers here. The cube root of 2 times the cube root of 2, I'm going to have to retain a cube root symbol and then just multiply the numbers. What's 2 times 2? 2 times 2 is 4. And so my final answer, guys, on number 7 is the cube root of 4 over or divided by just the number, no root of any kind, 2. Let's finish up strongly on number 8. It's not easy, but I don't know if it's as hard as what it looks either. Square root of 18a squared, b, c squared, divided by the square root of 9a, b cubed, c cubed. The first thing I'm going to do with this one is I'm going to line them up as a fraction. I think these help to do that. And so I'm going to put 18a squared, b, c squared over, okay, but let's not forget that's square root, easy to do. Square root of that term over the square root of, let's do that first on this one, 9a b cubed c cubed. Okay? So I have all these written correctly, right? And they're lined up properly on top of each other. Now we can write those separately, and we can write them together and it's all the same thing. We understand that by this point. Together, separate, separate, together, equal to each other. Either way you look at it. So when I do this math, I'm going to go ahead and I'm going to toss all these together into one. Okay, and it's the same thing as if they're separated, no big deal. Okay, let's just start with our terms. So what is 18 divided by 9? What's 18 divided by 9? That is 2. And since the larger number is on top of the fraction, I keep the number into which it'll evenly go, I keep that on top, since the larger of the two is on top. And by the way, that's how I determine also with my variables. Which one goes where? Well, it just depends on where the larger one is. That's the way it works out. A to the second divided by, okay, A to the second divided by A to the first. So subtract those exponents. 2 minus 1 is what? A to the first. And the larger one started on top, and so I'm going to keep it on top. Okay, B to the first divided by B to the third. Exponents, what's 1 minus 3? It's negative 2. Okay, 1 minus 3 is negative 2. And I can write it all on top as B minus 2. I'm not going to do that though. What I'm going to do instead is write it on bottom. And when I write it on bottom, I can write it as a positive instead of writing it on top as a negative 2. And you recall that section, whenever, if we had a negative exponent, we just flip it to the other side. That's what we're doing here. Since the larger's on bottom, let's go ahead and write our answer on bottom, and that way we can keep it positive if we do that. All right, c squared divided by c to the third power. Subtract those exponents. 2 minus 3 is negative 1 if I were to write it on top. But if I just keep it on the bottom, I can write it as a positive 1. So it would just be c, and it is on the bottom. So here's what I have. Under the same square root symbol, I have 2a divided by b squared c. Guys, what I'm going to do now is break these back up, okay? It's equivalent to the square root of 2a over the square root of b squared c. There's a reason I'm doing this. Stay with me. This is a long problem, and it's number 8. It's kind of like your number 6 on a quiz. You know, it's a brain teaser. It's one of the most difficult. It is the most difficult. So understand that and accept it for what it is. I can't do anything in simplification for that 2a on top, correct? I can do something on bottom though. Since that's a squared, and I have a variable that is raised to the second power, what can I do with that b squared? Remember, since that's understood to be a 2, because it's a squared, it's just not written, I can divide that square root power into the exponent of the variable. And what's 2 divided by 2? That's 1, or b to the first power. And because of that, I can pull a single b to the outside. Okay? I can pull a single b to the outside. And so what I have is b square root of c on the bottom. Is that okay for a final answer? Yeah, absolutely not. And the reason is, in rationalizing the denominator, I cannot have any root of any kind in the denominator. Right now I have a root, and it's a square at that, but a square root of c. So how do I get rid of that square root of c on the denominator? I multiply the square root of c on the bottom. And whatever I do to the bottom, I have to do to the top. So that on top, and remember when I multiply, I can combine these together. I have square root 2ac over b remains, but whenever I have two c's with square roots, how many c's do I have outside of a square root? Just a single one. Because think about it, if I have c, I multiply them together, and I have the square root of c squared, because if I multiply together, I have c to the second power, right? And if I have the square root of c, understood this is a root of 2, and I divide that into that, I can pull out of that what the answer is, which is c to the first power. And that's why I can just drop, just like I did with all the number ones, I do the same thing with variables. I just drop the square root symbol. And so my final answer is the square root of 2AC over no square root symbol, BC. And I can't cross these out because one's under a square root symbol and one is a standalone, and it is not. But I have a correct answer now because I have no root of any kind in my denominator. That is all she, or in the case of me, thank you very much, he wrote. So that's our lesson today, guys. I know these have been some pretty tough ones, okay, but just keep plugging away. You're doing a good job. And don't forget your second quiz now. Okay, you had 2 in this chapter. This is the second quiz that is assigned today, which being Wednesday means it will not be due till gloriously, will not be due until Monday. So you have the weekend to work on it if you want. Guys, shoot me messages, give me a ring if you have any trouble with these, and I'm glad to help you through them. And don't forget too, unlimited correction for 100% credit in your homework. Since we're away from school, that's a benefit that I'm giving to you, so be sure to take advantage of that. Okay guys, I'll see you for your last math lesson of the week tomorrow.